In Chapter 7, we talk about finding the area under the curve associated with a single z-score. Let's do this together now. Let's say that you see this symbolic phrase that looks like this. Now, what is this telling us? What is this indicating? This is asking for the probability, or P, that's associated with a z-score or z-scores that are greater than 1.20, right? Or the symbols can also be read as the proportion of the area under the curve that is associated with z-scores greater than 1.20. Now, as I've been encouraging you to do throughout the book, let me just take this away so that's not confusing, that's a small p. Always draw, especially when you're getting used to working with the normal distribution, draw it. Don't just get anxious because it's some vague concept in your head. These concepts are very concrete. Watch this. We're going to draw a normal distribution, right? Tails don't touch the abscisses. Okay, and we put in the mean. The mean is 0. And remember, we measure the normal distribution in standard deviation. So let's just do a rough approximation here. It doesn't have to be exact. Remember the idea, oh, that's definitely not exact. Okay. Remember the idea here is just to get these concepts very concrete in your thinking. Okay, there we go. That's a little better. 2. Okay, so what do we have here? You should all know this by now. This is positive 1.0. Positive 2.0, these of course are z-scores, positive 3.0, negative 1.0, and again this is approximate, these aren't exact, but they don't have to be exact for this purpose. Alright, so we're asked to find the probability, that is the area under the curve associated with a z-score greater than 1.20. So if we just do this roughly, we say, okay, here's 1.0, so 1.20 is probably going to be right about here, and let's draw it in with little dash marks. This is 1.20, right? And it's positive 1.20, and that's important, as we know. Okay, so we'll say approximately. Okay. Now, one very important thing to do in all of these exercises where you're being asked to determine the area under the curve, as we've said in the previous example, always draw the thing for yourself, the distribution for yourself, and then ask yourself, am I being asked for the larger portion of the curve or the smaller portion of the curve, right? In this case, greater than 1.20 is this. Now look at this visually. You can see very easily this is the smaller portion of the area under the curve, right? And so if we want to know the area under the curve associated with this, we have to go to our table, and here's our table that I hope you've printed out by now. This is done in a way that's long, but it makes it a little bit easier to use. And we identify 1.20, we find 1.20 under our z-score list, and these are the areas under the curve that are demarcated by a z-score of 1.2. The larger part of the area under the curve is 0.8849, the smaller part is 0.1151. Now we know by looking at our picture here that we're looking for the smaller portion of the curve. So the correct answer is this one, 0.1151. So we know now that this proportion of the area under the curve is 1151, and that means that the probability of someone in your population getting a z-score of greater than 1.20 is 0.1151, right? Or you could also say the percentage of scores that will fall at a z-score of 1.20 or higher is 11.51%. And that's true for any distribution of scores that are normally distributed.